Hello everyone, welcome to the channel. And I was not posting any video because my computer was broken, so I built a new custom PC, and today will be the first video on that particular PC. So last we were discussing about data structure, and last data structure we were discussing was binary search tree. So today we're going to discuss about new data structure called heap. Okay, heap is a very important data structure because it used to solve many problems. Why? Because see, heap is particularly an array that will self-arrange itself to give the max item or the min item of that particular array in OF one time when we want it. So this property of min and max heap are very useful solving many problems. So let me explain how the heap works. For example, just consider a mean heap. Mean heap in the sense the minimum item should be at the top all the time. So it's an array, right? And just assume that we entered a item 5. So 5 is the only one item. Then we entered a item called 4. 5. Now we inserted 4. Now what's going to happen is now it will check what is the parent of 4. So parent of 4 will be, see it as a binary tree. So we can, and every node has 2 children. Think this is the left children. So to find the parent, we will be doing it like I minus 1 by 2. Okay, so what happened here when we insert 4 will be the index 1. So 1 minus 1 by 2 equals to 0. So parent is 0. So is 5 greater than 4? Yes. Then we have to swap it because we are creating a mean heap. So now what happened? It's gonna get swapped and our item becomes 4 and 5. Now let's assume that we entered another item called 3. Now again it will check for its parent, right? And what's gonna happen now? 3 for 3, if we calculate the same thing, okay, now our item is 4 and 5, right? We try to enter 3. So what's gonna happen now? 3's index of 3 is now 1. So 1 minus 1 equals to 0 by 2. So parent index will become 0. 0 is 4. 4 is greater than 3. Yes. So we have to swap. Then it will become 3 and our last item become 4. So you see now always our minimum is staying at the top no matter how many items we are inserting, right? So this is how while inserting the logic gonna work. But now what happens if we extract one item? For example, yes, 3. If we extract 3, our minimum item will become 4, not 5. And 5 will be coming to the top if we remove 3. So the logic will again need to be implemented so that this heap need to be self-adjust. So let's now remove 3 and see what happens. Now remove it. So we get our minimum item. Now our 0th item will become 0th item becomes 5. 1th item becomes 4, right? Now it will check from parent to the children. So to find the left children, it will become our parents index is 0. So 0 into 2 plus 1, that is 1. This is the left child, and 0 into 2 plus 2 is equal to right child. Here we are not gonna having our right child, but our children index will be 1. So now what happened? It will compare right and left, assume that there is another element, and whatever the minimum of these two, it will swap because 5 is larger than 4. Let's 4 is minimum and it can swap it. So next time our item 4 will become our top item and 5 will become the next item. So when we remove, our comparison logic will work from top to bottom, and when you're going to push the item, our comparison logic will be from bottom to top. So this is for min heap. For max heap, just the compare logic will change. Here we're gonna checking for the minimum item and put swapping. For max heap, we just have to check for the max item and swap it. That is the same. And every time we're gonna have access to our top item, that is 3 in OF one time. Oh, you know, so whenever we want to minimum item of the heap, we just have to make main heap of top. That's a heap of 0, right? Heap of 0, and this heap of 0 always will give us you know, the minimum item, heap of 0, top or heap of 0. This would be always the minimum item of the array. And if it's a max heap, that will always be the max item of the array. Now then, let's try to implement that using JavaScript. So we're gonna implement a min heap. Okay, class, call it min heap rather than heap. Let's export it. Yeah. Now then, we're gonna create a constructor. Constructor will be taking nothing, but it will create a this dot heap. I'm gonna create a blank array. That's it. And now we're gonna create an add method that will help us to put value in the heap. So let's create add, right? It will take a while, and we're gonna push that value, this dot heap dot push val. And once you push the value, we're gonna run the logic to compare you know, its parent and swap it. So let's create another heap, another method that we can call heap up, and then it's gonna create, let's see, let ci equals to, that is the children index, that is the last index of the heap, this dot heap dot length -1. Now let pi equals to math dot floor ci -1 divided by 2. Now while pi, we have to check pi should not should always be greater than 0, greater than or equals to 0, right? We're gonna keep comparing it. Now we're gonna get the pi here. It's better. Okay, no, we have to get the first one here, then we have to repeat it here again, but it's fine. If this dot heap of pi greater than this dot heap of ci, then we have to swap it, right? To swap, we're gonna use our proper JavaScript swapping method, like ci equals to this dot heap, then ci, and we're going to use this dot heap pi. So this is going to swap it up. Then we have to calculate our ci will become pi. Ci equals to become pi, and pi will be calculated again using this. So we're gonna this dot heap up. So arrow is gonna heap up. Now get top. Let's create the top method. Top will return without mutating the top value. So this dot heap of 0 to return it. Perfect. Now we have to move pop, right? If we want to remove a value, pop, and then return, no, not return, let top equals to this dot heap. We have to do it from the top, so we're gonna have to use shift, right? Then we have to create another method that will heapify down. Heap down. Now same way pi. So let pi equals to 0, right? While pi less than let's create another method called size return this dot heap dot length. So heap dot size -1 dot size, dot size. Now let LC, that is left child, equals to pi into 2 plus 1, right? And let our right child equals to LC plus 1. We don't have to write it again. So now let mean equals to mean mean index equals to, or I can say mean index equals to if, or we can write LC, sorry, this dot heap LC smaller than this dot heap RC, then mean index is LC, else RC. So we're comparing what children has the smallest value, and based on that we're gonna create our child index, right? Then if this dot heap mi smaller than this dot heap parent index, then we have to swap this dot, the same thing again. We're gonna use this here, and ci will become mi. Perfect. Now your pi equals to mi. Now something, this will be again gonna go below, so we're gonna here, we're gonna, once we pop this dot heap down, we're gonna have to run that function, then return top value, right? I think this should do our trick. Let's try to test it. So main heap, perfect, main heap, fine. And what happened, we are entering, first we are adding 7, then we are adding 10, then 5, then 2. So last item we are adding 2, but it should be going to the first, the top. So when we accessing top, it should become 2. Then we're going to pop one item that would return as 2, and once we return this 5 item that is at the end of this array need to become our top item, that is that white, yeah, top item. So our minimum item should become 5 after removing 2, and our size should become 3 because we removed one item. So let's run the test and see what happened here. Oh, sorry, main heap. Cannot access main heap before initialization. Why not? Required main heap. Export class main heap. Yes, class main heap. We are exporting it. Now require, sorry. Count main heap equals to main heap. Let's try again. Okay, it worked. What happened with the pop? Heap dot size. Oh, sorry, not heap dot size. We should call this dot size, right? Yeah. Let's try it. Run test. Perfect. So that's how our main heap is. So now what you're going to do if you want to implement a maxif? So you're going to use the same code and do our maxif in our next video. Thank you for watching.